Hey everybody, and welcome back to the Human Resource Machine. Let me get started here. That's right, we were at Countdown. Totally forgot about this. We were working towards efficiency. So, as a reminder, we managed our number of these efficiencies. And now we need our number of executions. We used 10 commands, we used too many steps. So we have to do better in steps. So we're just going to go ahead and clear. Because we want to do everything really efficient. So we're going to be doing a couple things. One of them is we're going to be doing... well, I'm gonna start from the beginning, just as a reminder for everybody, if you don't remember the last episode. We're taking a number and we're counting all the way back to 0 with it. So we take it from the inbox. We have to copy it to, we're going to copy it to 0. Sorry, those comments are a little silly. We're going to copy it to 0, and then we are going to put it to the outbox. We don't actually care what it is at that point. So we're then going, actually we do. The problem is we do. So then we're gonna copy from 0. So if it is 0, see, the thing is, we need to do this as efficiently as possible. And if you remember from last time, there are 3 cases at this point in time. So after we've taken something, copied it to 0, put it into the outbox, and then copied it back from 0, we got 3 options. It is either positive, negative, or 0. They've kindly lined up all these options for me. Oh no, my mouse isn't being captured. That's not good. I'm gesturing with my mouse, and I just noticed that it's not being captured. I can change that. Can't I? Oh my. This is not good. There we go. I don't know why it wasn't being captured before, or at least I wasn't seeing it captured before. So, positive, negative, 0. That is the case we can be at right here. So what we want to do is we want to jump if negative, and we have to jump if 0. Which case is more likely? Well, if neither of those is true, which means it's positive, we bump negative. 0, yeah. And we outbox. And then I think I figured this out. Maybe. Alright, so here's the thing. If it's positive, we know it's going to stay positive until it hits 0. So what this does is, if it's negative, it goes here. Right? We don't care. If it's 0, it goes here. If it's positive, we bump it negative. We bump it. We outbox it. And we copy from 0. We jump, if it is 0, to this, which will eventually output. But otherwise, we jump immediately back. Actually, oh, here's a good question. I actually need to see how this works. So, the reason why we need to check how this works is if you bump from 0, does it give you the copy of the number? Because then we don't have to copy it from at all. So we copy 0, we put that in the outbox. Exactly what we want. Then we copy from 0. We do not jump because it is not negative. We do not jump because it is not 0. We bump negative, which makes it 7. We put that in the outbox. We do not jump because if you keep... Okay, you can't jump if 0 have empty hands. Okay, so we do need to... Darn. We do need to copy from 0. Or do we? Yeah, okay, this should work. This should work. We still have to do both of these. We still have to put it in the outbox. And we still have to jump if not 0. So which order they happen doesn't actually matter. So let's go ahead and get back to where we were. It's not negative, it's not 0, so we bump it. Put it in the outbox. Since it's not 0, so we jump. We bump it, and we take it! Yes! Okay, that is the answer to the question. That is one of the things that we don't actually have here. We don't have a good definition of what all these things do in every behavior. I would presume, and in fact until this exact moment did presume, that you had to have a number in your hands to bump it. But no, you just need to bump something in memory and then you get a copy of it. So once again, if it's 0, which it's so and then from here, put it in the outbox, rinse, repeat. Alright, so we can stop that. So we know that the positive case is going to work, and this is actually very efficient. It's not the most efficient, we still have to check if it's 0, but that's okay. So if it's negative, we're going to do something here. Yes, we do something here. Now, okay, I'll go back and explain why this ordering, jump if 0 and jump, is important, but we'll get there. So if it's negative, we are going to bump positive. Sorry, 0, yeah. And then just like this, jump if 0. Doesn't actually matter where, because you'll see. I'll get there, I promise. We'll bump it if 0, or we'll bump it. We'll jump if 0, and then just like before, we will outbox, and then we will jump back to here. So the way that the code was working before, and actually this will almost work. Now this will work. So, to get back to what I was going to go to earlier, what we did before is we created a general case, and the way that I approached it is, based on what we currently have, how are we going to treat it? So given any number off the floor, and you can go back and look at this code, given any number, if the number in memory changed, let's consider this. If the number in memory changed, let's say we put this 2 here, we put something in the output, and then before we get back, it is changed to -7. The code that I wrote before was robust enough that it would do the correct thing. It would go, oh, this is -7, it needs to go up. This code would actually break if that happened, and there's a reason why. We have our 3 cases still. Our jump if negative, which ends up here, our jump if 0, which ends up all the way down here, and our if it's positive, which of course, as I've mentioned before, is just it not going through either of those jumps. But once you end up in this situation, you end up in a jump until you are 0. This jump if 0 is the only way out of this loop, and it's always bumping down. So you just will keep going down. If for some reason, as you are doing this loop, 0 becomes negative, you will never reach 0 because you've suddenly gone from a positive to a negative number and you're only bumping down, and this will run forever. Now, in many cases, you don't have to worry about this. In many, many cases, you don't have to worry about this. And in this case, we also don't have to worry about this. But I wanted to point out how approaching this specific set of code is different. And I'm gesturing with my hands now. I'm not actually pointing at anything. I'm just gesturing, so I apologize if my mouse is very quiet, but or very unmoving. So within this loop, we have this entire self-contained loop that is assuming the number you have is positive. Now, much like that, this jump to negative goes here. And it does the same thing. It bumps it positive, and you only leave this loop right here, because this is always, unless you're 0. So if you have a negative number that suddenly becomes positive, just like before, or just like with this, it will stay in this loop forever because it never hits 0. Now the other important part is that the only way out of this loop is this jump if 0. So we can just point these all down here, because these all end in the same case. This is the other jump if 0. We always put the 0 in the outbox, and that means we're always going to start all the way over. I hope all of that makes sense. If any of it doesn't, go ahead and put down in the comment section below. The first code handled whatever you picked up off the floor correctly. This looks at your input and puts you in the correct loop, which runs a lot more efficiently because we don't have to come back here and say, hey, is our number negative? Do this. So let's watch. You'll see. So we got positive. Now it's a low positive number, so it's only going to be in this loop once. But it ends all the way back here, and then it goes back to the start. We put that -5 in. Now this will stay in, so this is the if negative loop. It's going to stay in this loop for a little while. So you'll notice it jumps. Its only way out. Can you imagine now if this became a 1? Then it would be a 2, and it would 3, and we'd never hit this jump if 0. I hope that makes sense. Oh, and we hit a 0, so we can put it in the outbox and we start all over again. Uh-oh, we have made a mistake. Okay. That's okay. That's actually good. So this is actually very interesting. We don't want to do this outbox and this copy from. We don't. Because the 0 case doesn't work there. We already put the we always put the first number out, and then we're always assuming that when we hit that 0 case that we're putting it into the outbox. So we don't want to do it that way. That actually takes out 2 lines of code, but it's gonna lead to a little bit more execution. So look, there we go, another mistake. That's okay. But what this means is there actually an undo button? Yes, there is. Okay, so this means if 0, we jump. So we moved our jump if 0. This check. So by putting it in this order, we took the it's more likely to be negative case. It is going to be 0 the fewest numbers of time through this loop. So this will only be hit if 0 is the actual case. All the other jump if 0s inside these loops take care of the other cases. So we only hit this once. So by moving this up here, we're not actually changing the way the code actually behaves. Instead of going to the outbox here, it'll go down and go to the outbox here, which is fine. Now, what it does mean is that we're going to run this command a little bit more often, because every single time it's negative, which is 1 in this case, it would go to this loop, and every single time it's positive, it would run this. Now, regardless of whether it's positive or negative, we are running this. So we've made it more consistent, but we are going to run, in this case, 1 extra command. So hopefully that's not the make or break here. But let's watch it now. Alright, we put out our default, we copy from 8. Okay, and now we're going to end up in our positive loop for a little bit. So we know that our positive case is working. Now, this interim, we've proven that we can go from 8 to 7, 7 to 6, 6 to 5, 5 to 4. We can assume that we're going to make it from 5 to 4, 4 to 3, 3 to 2, 2 to 1, and 1 to 0. But when we're at 0 is going to be the next important thing to look at. That's the next case where something changes in the way it executes. So we jump if 0, great, right to the outbox. We pull from the inbox, we copy it there, we put it in the outbox because it wasn't 0. All right. Now we're in our negative loop, where we just bump it up. We are running on average 4 commands every number. Which isn't great, but it's still not bad. Now once again we have to watch as we get closer to 0, because that's going to be important. If this doesn't come up with efficiency, I'm going to be a little stumped and we're going to have to figure it out. Alright, now here's the other important case. It's 0. This broke last time. It jumps to 0. Cool. We can pretty much assume that this one's going to work. So we'll just run through it real fast. Nice. That was pretty efficient too. Our size challenge was off. But our speed... 4 commands. We're 4 commands short. Well, long. Okay, but that means we can work with this. What can we do to improve this? We don't need this. In fact, that is it. That is our number. We did not need to copy from at all. And in fact, that is 4 commands. Oh, right. Okay, this is okay. Watch, we'll fix this. So now we need to jump beforehand. So we're gonna move this outbox to here. Well, we don't need that one. This is gonna work just fine. So instead of doing our outbox here, we're doing it here, which allows for this to fall through properly, just like what we did before. Just like when we reorganized this to not use copy from, this should work. And we're in the right place. Alright, so we know our positive's working. So let's watch our next case with our negative. Okay, we end up in the negative loop. Our 0 case worked. Alright, so this organization worked and we got rid of a command. 83. Okay. Oh. There you go. See, this ordering is going to matter. We ran this command. So here it always ran. See, okay, so positive runs here. So for that, 2 commands. And then we ended up going through here. Negative, we ran it extra. We ran it 1 extra. Oh, you cruel fates. So even when I thought we had it, we still had a little bit of tweaking to do, but it turned out that this was the right way. I think we got it. I think we did. Don't cheer just yet. Yes! There we go. And that is optimizing. That is optimizing. Oh my gosh. Oh, there's so many puzzles left. I love it. Okay. Multiplication workshop. It seems like only yesterday we were learning about adding. Fond memories. We worked so hard back then. Alright. For each 2 things in the inbox, multiply them and outbox the result. Don't worry about negative numbers for now. You got labels. They can help you remember the purpose of each tile on the floor. Just tap any tile on the floor to edit. Okay, so here is where we start really introducing some coding concepts. Right now, or I shouldn't say coding concepts because we've already been talking about coding concepts. Here's where we introduce a little bit more of coding language as it exists in the modern world today. As I've mentioned before, these commands are at the very least relative to something. I mean, add and subtract, bump. Some of these behave in odd ways, but they make sense for what they're supposed to do and how they've been explained to us thus far. But in real code, we aren't just referring to memory 0. Or in this case, this is memory 9, but 9 is labeled 0 right now. Oh, wow, these are actually done. Oh, that's fantastic. We actually draw them. So this is memory address 9. This looked like memory address 9. Can I actually... No, I can't change this. So this is hello. This could be... Oh, you can click on any of them. Oh, that's really cool. But what really is going on here is if you've ever looked at any code ever, this is like X, and this is like Y. Your memory addresses are basically your named variables that are supposed to help you learn how to do things. So X and Y are what we want. X times Y is what we're trying to get. So you can think about it like that. In a really simple program, we'd say X equals 4, Y equals 3, return or output X times Y. And then we'd have a loop that correctly assigned for this 4, and that's 6, and that 2, and that 0, and so on and so forth. So, for each 2 things in inbox, multiply them and outbox the result. Oh god, they're having us manually. Okay. That's okay, we can do this. So this is 0. I don't know why they had these here. No, whoopsie. Alright, so here's what we gotta do. This is gonna be interesting. Okay, so we're gonna call this result. And I apologize for my terrible handwriting. We've got X, Y, and result. The reason why this is named result is because result isn't gonna be correct the entire time. So we're going to copy from 9. So 9 is actually 0. We're going to copy from 0 because we know that's a 0. Actually, we're not going to do that right away. We're going... Yeah, no, we're not ever doing that. I lied. Alright, so we're going to multiply the first by the second. So we're going to take from the inbox. We're going to copy it to X. We're going to take from the inbox, and we're going to copy it to Y. The way we have to do this is basically we have to bump X, Y, or we have to do it Y time. We have to add X, Y times, or add Y, X times. So we're actually going to copy this to the result. And then we're going to bump down X. So X is going to go down 1 because we got Y in there once already. Oh, they have zeros. That's mean. That's mean. Alright, so we're going to have to do some stuff, right? So they're saying don't worry about negative numbers just yet, and that's because this is really hard to do with negative numbers when you're doing an addition like this. There's a way, but we'll get there. Okay, so how do I want to do this? How to go about doing this? We obviously need a loop. We're gonna need this to be in a loop. And we're gonna need a loop in here. So we've got Y. We've got X here, Y there, Y there. And then we bump X down. Now obviously this isn't gonna work just amongst itself. Because we bump X down, and then we have to, if X is 0, then we're done. Then we copy from results and outbox, because we know we're good. Because that means we've added this the correct number of times. If it's not 0, Okay, I see. We actually do need to do something silly. Alright. We are going to copy from 0 and copy that to the result. Because we don't want to be copying to here, we want to be adding. We want to add y to the result. And then we want to copy that to the result. This is so plus equals, it's driving me crazy. I can't, if you don't know what plus equals is, don't worry about it just yet. But oh god, that makes all the sense in the world. Looking at coding concepts that are very simple, like multiplying isn't something you will ever implement, or will ever need to implement in this fashion. But because we're doing it in this way, it makes you think about the process, and it makes things a little bit clearer. So enjoy that if you already know how to code, or if you look back on this and realize, you will probably realize at some point in the future. So let's go ahead and watch this execute, because I don't think this is going to work, and I just want to see how it functions. Okay, so we copy from 0 and put it in result. So we take our inbox. Oops. I have this loop wrong. That's okay. That's okay. We'll see. We copy that to y. So we add that to the result. So we've added it our first time. We copy it to our result, and we bump down x. So we already have one of our 3s. We need 3 more 3s, if that makes sense. It is not 0, so we jump. Now this copy to y is terrible and is wrong. So really it should be this. We copy to y. We then copy from y. Yeah. This is a bit redundant, but it has to do with the fact that when we bump x here, we end up with x's new value, and we need to get back to y. So this is a little inefficient, and probably isn't going to come out with the efficient strategy, which I honestly haven't even begun to think about. I'm just thinking about implementing this. All right, so this might actually work. So we copy 0 into result, because we cannot use the add function unless we... Actually, I don't know that for sure. I don't know that for sure, but we're still going to have to do it, and I'll explain why in a bit. So we store our variables again. Alright, so we copy from y, which we already have. We add result. We store it in result. And then we bump down x. So we have 1 5, we need 8 more 5s. Make sense? So it wasn't 0. So then we copy from y, add the result, bump down x, and as you can see, it's still not 0. You can see where this is going. I'm going to just be mashing through this, and it's going to make sense here. Unfortunately, we got a big number, so it's not going to work all that well. Or it's going to just take some time here. And this actually should work. I do have a copy from result there. Okay. So we need 2 more y's. We add, we copy. Bump. We add it 1 more time. Copy to the result. So 5 times 9 is in fact 45. It is 0, so we jump. So we take from result. We output it there. Now here's why we need this. So depending on how your loop is written and what language, most often the way a loop will work, or the function that you call, it kind of cleans up its variables before you deal with it. This doesn't do that. So if I don't have this copy 0 to result, we end up with the problem of I'm going to start adding on top of this 45, which is not correct. So we copy from 0, put it in 45, and we start going. Now, this isn't going to work because of zeros. But we can actually short circuit this. So we can basically say, hey, if this is 0, just put it in the outbox. Just like we can go, if either of them is 0, we go straight to the outbox. Now, this is also a little inefficient because we'll be checking it each time, but oh well. It'll actually probably save some, it might save some time. So we're going to speed this up a little bit. 2 times 5, so 5, 10. 9 times 9, this is going to take a little bit of time. But watching it go fast lets you see it. Uh-oh. Alright, we had a problem. So what went wrong? I actually want to know. Oh. Dang it. Okay, I know what happened. I know what happened. We went, so the first one was 0, so we had 0 times 0. Oh, you fiend. Okay. There's a way to do this. Oh my gosh. Oh man, never thought I'd be 0 checking. So I'm trying to find it. So the reason, as just to clarify, since I don't know if it was entirely clear, there are 2 zeros. 0 times 0. So when I copied it, when I took it in here, I jumped all the way to the end and went, hey, it's a 0, outbox it. Which doesn't work. It doesn't work because we still have a 0 as the second input. So we returned and we still had the wrong number of things because now it was offset and it was 0 times something else. So we output a 0, which was incorrect. So, at least I think that's how it went. No, sorry, that is not how it went. It was 4 times 5, 2 times 6. Those would execute properly. We'd pull 9 here. We'd pull 0. I had the jump, which put it there, which was fine. That worked. But then it's 0 times something else, which we pulled from the inbox, and it went straight there. And whatever is next in line gets pulled as the X in the next one, and then the Y is wrong. Does that make sense? Here. I don't think I'm making decent sense there, so I'll show you what happens. These multiply. The 2 times the 6 happens. So, oh shoot. Well, this is going to cause problems, but that's okay. So, because I don't have the actual code in there, so I can't show you what it did. So it copied, we pulled the 9, and it went, that's cool. Put it in there. We pulled the 0, it went, hey, that's a 0. Go put it in the outbox. Now this is going to do some really wonky crap. Actually, this will work. Believe it or not, this will work. Actually, this will still work. This will still work because we're adding 0 a whole bunch of times. The next one will break, though. So we got 0. That's right. We just added 0 to itself 9 times. So we put a 0 in the result because we need to. We inbox a 0, put it in X. We inbox a 2, put it in Y. We copy from Y. We add the result. We copy the result. We bump X. X is negative. It's not 0. This is going to go forever. I actually want to know what this does if it goes forever. So this is more a point of curiosity for me. We've managed to get it into a state that we don't have a handle for and no way to escape. So it's going to do this forever, funnily enough. Now, there is an easy way out of this, which I've just figured out. Okay, it's just going to go forever. So here's the fix. If the second number is 0, it works because we're adding 0 a whole bunch of times. If the first number isn't, this jump if 0 check fails. It never happens. So we jump if negative, and we put it here. If we do, we copy from 0 and outbox. Well, we'll copy from 0 and jump. Oopsie. We'll just jump all the way to the top. Copy from 0 and outbox. It's actually the same. No. Yeah, if we jump here. So, and then this jump if negative, this jump if 0 passes that. So, this will work because when this is negative, it'll know to go here. Now, this is, I don't think this is going to pass on any of the efficiency stuff. So you'll notice that this is working just fine. Now this 0 will happen a whole bunch. So here's where we're interested, and I'm glad I managed to stop it in time. We bump X. It's -1. So it's not 0, but it is negative. So we copy from 0. Because the only way the only way this happens is if this was 0, because we're bumping it before we're checking. It's just that simple. And we haven't messed up our numbers. We've successfully pulled 2 inputs. Now, this is 16 lines of code, 17 lines of code. How many lines of code? Way too long. So this is inefficient on all fronts. So what does that mean? It means that next episode, we're going to make this efficient. Next episode. Which sucks, because I really want to do it right now, but I'm going to wait. So, I hope that you guys enjoyed this episode. I will see you next time when we try and make this multiplication workshop a very efficient workshop. Nice and optimized. But until that time, keep your gears turning.